Hello, my distinguished students. Once again, you are welcome to our lesson series Math 103. Today's lesson topic shall be graphs of quadratic functions. Hope you enjoy the topic as we go. You are welcome. As you well known, my name is Dr. Adeluga Anjorin from the Department of Mathematics, Faculty of Science, Lagos State University. I'm the facilitator of
You are once more welcome to the lecture series on
Hello students, you are once again welcome to our lesson series in mathematics. Today's topic shall be graphs and the solution. I hope you will enjoy as we go. Thank you, you are welcome. By the end of this lesson, you should be able to 1. Define quadratic equations, solve quadratic equations using graphs, know what functions, domains, and ranges are. In this lesson, you will be introduced to quadratic equations again, how they are being solved using graphs. As you will be introduced to terms like domain, range of functions, functions of functions, or sometimes called composite functions, which we explain later in the next lesson. All this shall be demonstrated with examples. A function f is a quadratic function if f of x is equal to ax squared plus bx plus c, where a, b, and c are real numbers, with a not being equal to 0. If a was 0, then the equation will be a linear equation. The simplest quadratic function is given by f of x equals to x squared, with a equals 1, b equals 0, and c equals 0. To find some points on the graph of this function, we choose some values for x and find the corresponding values of f of x, as in the chart with figure 5.1 below. Then plot these points and draw a smooth curve through them. This graph is called parabola. Every quadratic function has a graph that is a parabola. The points are well displayed here. X has point -2, -1, 0, 1, 2, and the corresponding f of x, once x is being put into f of x, are 4, 1, 0, 1, and 4. These points are then plotted on the paper to obtain the curve you are seeing. Parabolas are symmetric with respect to a line, the y-axis. The line of symmetry for a parabola is called the axis of the parabola. The point where the axis intersects the parabola is called the vertex of the parabola. These are shown in the diagram below, 5.1 above. The vertex of a parabola that opens downward is the highest point of the graph, and the vertex of a parabola that opens upward is the lowest points of the graph. These are shown, the one that opens downward and the one that opens upward. Given a graph g of x equals ax squared plus ax squared, which is parabola with vertex at the origin that opens upward, if a is positive and the graph is and downward if a is negative, The width of Gx is determined by the magnitude of A. That is, Gx is narrower than f of x equals ax squared if the modulo of a is greater than 1, and is broader than f of x if the modulus of a, the absolute value of a, is greater than 1. By completing the square, a technique well known to you as discussed in lesson 4, any quadratic function can be written in the form h of x defined here, a x minus h bracket squared plus k. The graph of h of x is the same as the graph of g of x because a x squared translated h units horizontally to the right if h is positive and to the left if h is negative, and translated k units vertical or if k is positive and down if k is negative. Example, consider the graph a gs equals minus half x squared. The function gx can be brought off as minus the graph of half x squared is a broad version of the graph of x squared, and the graph of gx equals minus bracket half x squared is a reflection of the graph of yes, because one is positive and the other is negative. This is well explained in the diagram below. You can see the diagram. The negative one is gx and the positive one is upward. So they are a reflection of each other. One is negative, one is positive. Consider the function h of x equals half x minus 4 squared plus 3. The function hf is g of x minus h plus k, while g of x is the function of example A above. H is equals to 4 in this case, and k is equals to 3. Therefore, h of x is obtained by translating the graph of gx 4 units to the right and 3 units up. You can see the figure below. The vertex of this graph is 4 and 3, and the axis of the parabola is the line x is equals to 4. This is well displayed in figure 5.3. In general, the graph of the quadratic function f of x equals a x minus h to bracket squared plus k is a parabola with vertex hk and axis x is equals to h. If the parabola opens upward if a is positive and opens downward if a is negative. With these facts in mind, you will apply completing the square to the graph, to the equation of the graph of the quadratic function. Example, given the function f of x equals to x squared minus 6x plus 7. This function can be written as x bracket x minus x squared minus 6x bracket close 6 plus 7. To graph this parabola, x squared minus 6x plus 7 must be rewritten in the form of x minus h squared plus k. You start as follows. You write f of x as x squared minus 6x bracket closes plus 7. As shown earlier, a number must be added inside the parentheses to get a perfect square. To find this number, take half of the coefficient of x and then square the result. Half of minus 6 is minus 3, and the square is 9. Now add and subtract 9 inside the parentheses. Group the terms and factor as follows: x squared minus 6x plus 9 minus 9 plus 7. Fx equals x squared minus 6x plus 9 minus 9 plus 7 will now give us the function in the parentheses, a square function. And minus 9 plus 7 is equals to minus 2. So this leads us to a function of the type x minus 3 squared minus 2. The result shown that the vertex of the parabola is 6 and k, and the axis and k is 2. The vertex of the parabola is 3 and minus 2. And the axis is the line x is equals to 3. The graph is shown in figure 5 above. Slide. Graph of a quadratic function. The quadratic function defined by f of x is equals to ax plus bx plus c can be written in the form x minus a squared plus k, that's completing the square, where a is not equals to 0, and h is equals to minus 2 minus b over 2a, and k equals f of h. That is by substituting whatever you have as h into f, and that will give you exactly what k. The graph of a quadratic function has the following characteristics. 1. It is parabola with vertex hk and the vertical line x is equals to h as axis. 2. It opens upward if a is greater than 0 and downward if a is less than 0. 3. It is broader than y. It is broader if the absolute value of a is less than 1 for function y is equals to x squared, and narrower if the absolute value is greater than 1 for function y is equals to x squared. The vertex and axis of a parabola can be found from the equation either by completing the square or by memorizing the formula h is equals to minus b over 2a and letting k be function of h. You have some activities you can go through by finding their vertex, drawing the graph, find their axis, and this will get you understanding this lesson. These are also some activities you can treat on your own. Algebraic equation up to those of degree 2 have been provided. The graphical methods of solution are also introduced. Steps for carrying those solutions were also carefully explained. At the end of this lesson, you should have the good knowledge of how 1. To draw a graph of a function, 2. Obtain the vertex of the graph, and 3. Interpret the graph of any quadratic function. We have some references you can